Good afternoon, everybody. I am just going to work through a couple more problems to help you get ready for your quiz if you're struggling with a couple of questions. So we're doing sections 3.4 to 3.6 quiz that you will be having. So I'm on the notes that you had a few more challenging problems. I want to quickly work through this one where you are going to find the formula of oxide. So the first thing that you need to do, you have a 2-gram sample of oxide of bromine is converted to 2.936 grams of silver bromide. So we're going to calculate first the amount of bromine that is in our silver bromide. So we're going to do the percent bromine in silver bromide. So I'm going to use the molar masses. So the molar mass of bromine is 79.9 grams per mole over the total molar mass of silver bromide, which is 187.8 grams per mole. Do the calculation on that, and I get 0.425% or relative abundance of bromine. I'm going to multiply that by the amount of silver bromide that I had, which is 2.936 grams of silver bromide. And that's going to equal 1.25 grams of bromine. Okay, so then all I need to do to get the oxygen is I'm going to take my original sample, which was a 2-gram sample. I'm going to subtract out the bromine because I know there's only bromine and oxygen in there, so I can subtract that out. And this is going to give me 0.750 grams of oxygen. And so I'm going to go ahead and now do my empirical formula. So I'm going to go back, I'm going to use my 1.25 grams of bromine, my 0.075 grams of oxygen, and now this is a straight empirical formula problem that all of you are familiar with. There goes the bell. All right, so I'm going to take 1.25, we're going to be doing the bromine ratio, 1.25 grams of bromine divided by its molar mass, which is 79.9 grams per mole. Now you can see that grams are going to cancel out. I am converting this to moles for 0.0156 moles of bromine. Then I can go ahead and do the same thing for my oxygen. And the mass of oxygen I have is 0.75 grams divided by the molar mass of oxygen, which is 16.0 grams per mole. Grams cancel out, and again I'm left with moles. And so my answer there is 0.0469 moles. And remember here now for the empirical formula, I want to divide by the lowest number of moles. So this is my lowest number of moles that I have, so I can find my ratio, divide both by that number, and I'm hoping that I'll get a nice even number, which this is equal to 1 and this is equal to 3. So I know that my formula is going to be BrO3. Again, just give the formula in the order that the elements are given in the problem. Okay, hopefully that one's pretty straightforward. I'm going to skip number 2 because that's just straight empirical formula, and I basically did that in this problem. I'm going to go to problem number 3. So for number 2, you have this answer right here. Go ahead and see if you can work it out. Remember that when you are given percents, you can just assume that in grams because we are assuming a 100-gram sample. Okay, so the last one that I have here is cumene, is a compound containing only carbon and hydrogen that is used in the production of acetone and phenol in the chemical industry. Combustion, so it's a combustion reaction. So the first thing is we know that we have carbon, we don't know how much. We have hydrogen, again we don't know how much, but it tells it's a combustion reaction. All combustion reactions are going to give us carbon dioxide plus water. Okay, let's go back up and write down what we're given. We are given that this is a 47.6 milligrams of cumene. I'm just going to convert that to grams right away so I don't have to worry about that later. I would divide by 1,000. And carbon dioxide, it says it produces 156.8 milligrams. Again, divide by 1,000. 0.1568 grams. And then I have hydrogen, which is 42.8 milligrams. Again, divide by 1,000, sounding like a broken record here, 0.0428 grams. Okay, so I am trying to find how many carbon and hydrogen atoms are in my formula. So the first thing I need to do is I need to isolate both the carbon and the hydrogen. So the first thing I'm going to do is I'm going to find the percent carbon in carbon dioxide. So I'm going to say that my molar mass of carbon is 12 grams per mole. And I know carbon dioxide's molar mass is 44.0 grams per mole. That cancels out, and I get 0.273 parts carbon. Now I'm going to multiply by the mass of carbon dioxide, 0.1568, and that percent is going to be just of carbon. So I have that total mass of carbon dioxide. What part is carbon? Would be 0.0428 grams of carbon. Now, because I only have 2 elements in my sample, now I can go ahead and I can subtract. I could go ahead and isolate the hydrogen out of water. They give us that mass. It's just extra information. You really don't need it. So if I'm going to find my mass of hydrogen, I'm just going to take the sample that was given to us. Sample. We know that it's just carbon and hydrogen, so I can subtract out my carbon. And I'm going to get 0.0048 grams of hydrogen. Now I'm just ready to do my empirical formula. So my empirical formula, I'm going to change my masses over to moles and divide by the lowest number of moles. So I'm going to start with carbon, 0.0428 grams of carbon divided by its molar mass. And that's moles. I will do the same thing for hydrogen. Because I have 0.0048 grams and the molar mass of hydrogen is 1, I know that I have 0.0048 moles of hydrogen. And remember, for empirical formula, when I get to this point to find the ratio, I divide by the smallest number of moles, which would be for the carbon. And when I do that, this is equal to 1, and this is equal to 1.3. Keep in mind that I can't keep that 1.3. I don't really know if it's close enough to 1 or not. So I want to multiply by a whole number that will make this a nice whole number. If I multiply this by 3, that's close enough to 4. I can't just do it to 1. I have to do it to both. And so this will also be 3. So now my empirical formula is equal to C3H4. And the first thing I want to do so I can find my molecular formula ratio is I want to find the molar mass of this. So I add up 3 carbons, 4 hydrogens, and the molar mass of that is 40 grams per mole. All right, great. They give us in the problem that the mass of the compound is 115 grams per mole, between 115 and 120. So to find my molecular formula, I'm going to use that ratio. So I'm going to take the mass that they give me, 115 grams per mole, divided by the 40 grams per mole that I got, and this was equal to 2.9, close enough to 3. You could quickly check the other one, 120 grams per mole. You can probably do this math in your head, divided by 40 grams per mole again, and I'm going to get 3. So I'm pretty confident that my ratio between the two are 3. So I need to take my empirical formula, which was C3H4, multiply all of them by 3 to get my molecular formula. So it's going to be C9H12. Okay, so if you can do those problems, you are going to be golden for the quiz tomorrow or whenever you have it. Keep in mind that watching me do it is much easier than doing it on your own. You have 5 book problems that were assigned. I'm not collecting them, but if you want to try them, I'm going to jot down the answers for you right now so you can check them out. So number 59 was one in that section. That would be good to do, and you're going to get 50% carbon, 5.6% hydrogen, and 44 0.4% oxygen. Okay, the next one I assigned was number 73 that you might want to take a look at. And that is your empirical formula. You should get to be sulfur mononitride, and your molecular formula is different, tetrasulfur tetranitride. Okay, 78 was another one. 78A, you should get 26.1% carbon. B, your empirical formula is CH6N2. And let's see, I think that was just A and B. And we're looking at number 112. Let me see if I can find that answer for you. So 112 asks for empirical and molecular formula again. So empirical formula is C4H3O2, and your molecular formula is C8H6O4. And then 117 was the last one in that section. It's asking for a percent yield, and I got 42.7% yield. Okay, hopefully those will help you out. I really want to make sure you understand between molecular and empirical formula. If you can do that, you're going to do great. Have a great night, and I can't wait to see you in class. Talk to you soon.